In this tutorial and the next 3 tutorials that follow this, we'll talk about an interesting topic called estimating correctly. You might wonder whether actually there is a science behind guessing and estimating. In fact, there is, and very good engineers actually have been practicing it for at least a couple of centuries. Guessing in the face of unknown is a hallmark attribute of great engineers. Let's see how they do that. Let's say we are faced with a problem like how many car mechanics are there in Moscow. Now I'm assuming that none of you are from Moscow, or even if you are not going to run to the yellow pages to solve this problem. And how can you even solve such a problem? How can you even come to a number that makes sense? There are multiple ways. People actually generate and guess randomly when they are faced with such completely unexpected questions. Is that the right way? Maybe not. The other way is actually have a group of people, entire team guess randomly and take average. Obviously even that is not going to be a very valid approach. There has to be a systematic process that one should follow to solve such problems. And let's look at what that process is. Always try to see what you know about the problem that is being asked. Or even let's take a step back and see, first of all, figure out what is it that you need to guess in this problem. When someone asks you how many car mechanics are there in Moscow, do you really need to start guessing how many the mechanics, or is there something else? Just step back and ask, okay, if I know the number of cars in Moscow, great, I can guess the number of mechanics in Moscow. So actually it's a question of solving the number of cars. Now even that is not an easy guess. So what else can I guess to guess the number of cars? Well, if I know the number of people in Moscow, maybe I'll be able to guess well. So the problem of guessing the number of mechanics actually boils down to the problem of guessing the number of people or number of families in Moscow. Great. So the first step is to identify what it is that you need to guess to solve these problems. Okay, how many people are there in Moscow, or how many families are there in Moscow? We don't know. At least I don't know, because I never lived there, I never went there. All I know is Moscow is a huge city, one of the largest in Europe, so it must be having a lot of people. However, I know about another city in southern part of India, Hyderabad, which is where I live. I know a bit about the people number. I know more or less accurately how many people live in Hyderabad. So in Hyderabad there are 8 million people. Is Hyderabad as big as Moscow? No. But is Hyderabad likely to have as much of population as Moscow? India is generally populated very heavily, so most likely Hyderabad must be close to some of the larger cities in the world. Still, I would believe that Hyderabad will not be able to be similar to Moscow. A top city like Mumbai, most populated city like Mumbai, should be closer to Moscow, which is one of the largest cities in the world. If Hyderabad has a 8 million people, Mumbai probably has 50 times more than that, 50% more than that, which is 1.2 crores or 12 million. I would estimate Moscow's population around that number. So intentionally I'm not going to internet to search for this number because I want to show you the technique. But one of the advantages of moving from what should be guessed to what you can guess is that it may be much more easier for you to find the answer for what you are trying to guess. Maybe it's very difficult to find on web how many mechanics are there, but population of Moscow must be straightforward. You should be able to look it up. But anyway, let's not go through that process. Let's try to guess everything from ground up. So Hyderabad may not be as populous as Moscow, but the most populous place in India, Mumbai, may be 50%, may have 50% higher population than Hyderabad, which should also be comparable to that in that of Moscow. So my estimation is 1.2 crores or 12 million. Great. Now, before we talk about this slide, let us talk about how many families are there in Hyderabad. So in Moscow, in Hyderabad, the family size should be around 5, but I assume Moscow being a more westernized city, I would assume the family should to be more nucleus, and so I would probably estimate it at around 3 per family. So Moscow has 12 million people or 4 million families. Now the question is, how many cars do you think a family drives? This number varies from rich countries to poor countries. In a super rich country like US, probably each family owns 2 cars. In a middle or lower middle class city like Hyderabad, maybe I can estimate on average 0.8 to 1 car per family, or probably even less. Moscow, I expect it to be somewhere in between, so I would assume that per family the number of cars are 1.25 to 1.5. Just let me say it is 1.5. So there are around 6 million cars in Moscow, assuming 1.5 cars per family. Great. We now have a number for cars. Then we need to estimate the number of mechanics from this car. In Hyderabad, again, as a car owner, I think my car spends around 7 days a year in a mechanic garage. But in India, driving is very rash, and there are minor accidents happening more often. I assume that Moscow probably people drive like in West in a lot more disciplined way. So I would expect the repair time of car to be lower. So let me estimate it to be around 3 days per year, as opposed to 7 days. The weather in Moscow is less friendly to cars. There is more ice and snow, so I expect more accidents, but I'll give it to more disciplined driving to have Moscow cars spend less time in the mechanic garage. So there are 6 million cars, and each car spends around 3 days in a mechanic garage. And I assume that when the car is in a garage, on average 2 mechanics attend to it. So that works out to be 2 times 6 times 3. That's how many mechanic days. Now I can actually divide it with 250, which is the average number of days of work for a mechanic in a year, to get to the number of mechanics. Now it's simple math. So we estimated that number of families in Moscow is number of people in Hyderabad times 1.5 gives me number of people in Moscow, and the family size of 3 when I divide gives me the number of families in Moscow. And so then I say cars per family is 1.5, number of repair days per year is 3, number of mechanic days, so because 2 mechanics are attending, I have to multiply 2, and number of mechanic years, which is 250 days a year. So once I divide, I should get the number of mechanics. So that is quickly, the math is 8 million times 1.5, which is 12 million, divided by 3, which is 4 million, times 1.5, which is 6 million cars, times 3, 18 million repair days, times 2, 36 million mechanic days. That works out to be 3.6 million, 144,000 mechanics. Well, you can do that calculation using a calculator, but 144,000 mechanics are needed. Let's assume there is a 10% more supply than demand. That makes it to around 160,000 mechanics. Now I want you to note one very interesting thing in this guess work that we did. Number one, we went very systematically, so we can correct ourselves very easily. So suddenly, if I get the information that, you know, in Moscow actually number of repair days are comparable to Hyderabad, then I'll change 3 to 7. Similarly, if I learned that Moscow is much richer than I thought, then cars per family has to be 2, then I'll just change that part. So once you set up a system like this, you can now research and plug in the right values wherever they are available and make the guesses wherever they are not. And you're guessing also very systematically about what you know. See the difference between this and starting with guessing. You know, there are million mechanics in Moscow. So what you need to do to solve such problems is first figure out what it is that you have to guess. You may not want to guess what is asked in the problem. Figure out, go 1 step, 2 steps, 3 steps below the problem level, and then figure out what is this fundamental thing that you can guess to get to the right answer. And then go from known to unknown systematically. Make a guess about start with something that you know and make a guess about what you don't know, connecting them logically. And wherever you cannot search for the answer, or wherever you don't know the answer, take an assumption. Make an assumption that you think is reasonable, but know that you can make multiple assumptions, but you have the chance to validate it also if you are going through this approach in most cases. Okay, great. Next week in the tutorial, what we will learn is when we actually work on a much more complex system about which are similar to which we don't know anything, and then we also don't know how to actually go down step by step to find out what we identify what we know and then make guesses. So we'll take a more complex problem. Thank you.